All right, let's dive in because today we're tackling really the absolute heart of IT, keeping those Windows Server environments safe and sound. Sometimes it feels like you need, I don't know, a secret decoder ring just to keep up with all the technical stuff, right? Well, good news. We're aiming to be your shortcut today. You've brought us a fantastic stack of resources covering the critical world of system administration, these cyber threats we keep hearing about, and the actual tools to lock down Windows Server, Active Directory, and even Hyper-V.
Exactly. And our mission, really, for you listening, it's pretty simple. We want to pull out those crucial bits of knowledge, not just what these sometimes complex concepts are, but why they genuinely matter in your digital world. We want to deliver those clear aha moments. So by the end of this deep dive, you should walk away feeling, genuinely well-informed and maybe a bit more confident about tackling these challenges.
Okay, great. Let's unpack this then. Maybe start with the unsung heroes of IT, the system administrators themselves. We hear sysadmin thrown around a lot, but for folks not living and breathing IT daily, what does that role really involve? Is it just fixing computers when they break, or is there a bigger picture?
Oh, it's definitely more than just fixing computers, though that's part of it for sure. At its core, an IT administrator or sysadmin is the person responsible for the upkeep, the configuration, and crucially, the reliable operation of computer systems,
Hmm.
especially those multi-user servers that, let's face it, form the backbone of pretty much any organization these days.
Okay, backbone's a good word.
Yeah. Their main goal, ensuring uptime, performance, resources, and, of course, security. Making sure all those systems meet what the users need while, and this is important too, staying within budget. Think of them as, I don't know, digital architects and guardians, kind of always on duty behind the scenes.
Architects and guardians, I like that. So not just reacting to problems, but actually planning and maintaining the whole digital structure. What kinds of things are they doing day to day? What are those responsibilities?
You got it. And yeah, the duties are incredibly varied. They're involved in acquiring, installing, upgrading hardware, software, you name it. They're also implementing routine automation, to keep things running smoothly without manual intervention all the time. Maintaining security policies, that's huge. And yes, absolutely, constantly troubleshooting issues when they pop up. Plus, providing technical support, keeping detailed documentation, which is vital but often overlooked.
Sounds like a lot to juggle.
It really is. And what's fascinating is how much the role's scope can change depending on the size of the place.
Hmm.
In a smaller company, maybe, a single sysadmin might wear a ton of hats. They could be doing network admin, database admin, maybe even help desk stuff.
Right, the jack of all trades.
Exactly.
Yeah.
But in a bigger company, these tasks often get specialized. You'll have dedicated database administrators or network administrators, security administrators, web admins, separate roles for each.
Okay, so it demands this blend of deep technical knowledge, but also serious versatility.
Yeah.
How do people actually get into this kind of demanding job? Is it always a traditional four-year degree, or are there other routes?
You definitely see a mix. A lot of people do come from bachelor's degrees in fields like computer science or
Mhm.
IT, information technology, and industry certifications. They're incredibly valuable. Things like Microsoft's MCSA or MCSE, maybe Red Hat's RHCE for the Linux side, Cisco's CCNA for networking, CompTIA's A plus EA, Network plus ET. Those are all common.
Right, those acronyms you hear about.
Yeah, exactly. But what's really interesting, and I think speaks volumes about the field, is that a significant number of sysadmins are actually self-taught. It really highlights the practical, hands-on, problem-solving nature of the work. You learn by doing, by breaking things and figuring out how to fix them.
That makes total sense. It's very practical.
Mm.
So if you had to pick one skill, like the absolute paramount skill that defines a great sysadmin, what would it be?
Oh, hands down, it's problem solving. No question. Sysadmins frequently have to diagnose and fix issues, often complex ones, really quickly, and usually under significant pressure. When a critical system goes down, everyone's looking at you.
Yeah, the clock is ticking.
Exactly. It's about that intense, focused thinking to figure out the root cause and get things running again before the impact spreads too far.
Okay. So we have our heroes, the sysadmins. Now let's pivot a bit and talk about the adversaries, the challenges they face in the digital world, this modern threat landscape. It feels like something everyone needs to grasp, not just IT pros. We've seen this huge global surge in attacks against computing infrastructure, haven't we? Fueled by everything from, cyber warfare between nations to organized cybercrime just looking for profit, and even hacktivism.
Absolutely. And the consequences are very real. We're not just talking about abstract data breaches. We see sensitive information leaks hitting the news all the time, theft of valuable intellectual property, crippling denial of service attacks, DDoS attacks that take websites offline, and sometimes even, destroyed physical infrastructure controlled by computers.
And the financial side of it is just mind-boggling.
It's truly staggering. Some studies put the annual global cost around $3 trillion. That's a trillion with a T, in terms of lost productivity, lost growth, and the average cost for a single security breach for a company. Somewhere around $3.5 million. That's the average.
Wow, $3.5 million.
Yeah. So this really shifts the mindset, right? The ultimate goal of modern security. It isn't necessarily to prevent every single attack attempt. Frankly, in today's world, that's practically impossible. Instead, the real focus has to be on protecting the IT infrastructure from successful attacks, building resilience, making sure you can withstand the hits and recover quickly.
Resilience, okay. That makes sense. So if preventing every attempt is impossible, how does a typical attack actually play out? Is there a sort of pattern or playbook attackers follow?
There often is, yeah. It frequently starts with the attackers doing their homework. Research and preparation, they're gathering intelligence, maybe using social media, LinkedIn, company websites, looking for potential weaknesses or targets.
Reconnaissance, yeah.
Exactly. Then they try to get that initial foothold, maybe exploiting a known vulnerability in software that hasn't been patched yet, or, very commonly, through a convincing phishing email that tricks a user into clicking a link or opening an attachment. They just need to breach one or two initial systems to get started.
Okay, and this next part, I think, really drives home the danger. Once they get that foothold, they move fast, don't they?
Terrifyingly fast. That next stage, privilege escalation and lateral movement, where they try to get higher levels of access and spread across the network, typically happens within, get this, 24 to 48 hours.
It's just 1 or 2 days.
Yeah. That can be enough time for them to gain significant control, maybe even domain admin rights over the entire organization.
Wow.
And what's truly alarming is what happens next. Once they're inside and have that control, attackers can often remain undetected, maybe quietly stealing data, installing backdoors, for a long time. The average dwell time, as it's called, is often over 150 days before the compromise is finally noticed.
150 days?
Yeah.
That's 5 months.
5 months of potentially unhindered access? Think about the damage that can be done in that time.
That's a huge window. Okay, so for you listening, this really clarifies the mission, doesn't it? That primary goal has to be extending that critical privilege escalation time, pushing it from just hours to ideally weeks or even months, because that extended timeline is your crucial window. It gives you a chance for early detection, for rapid response, and that significantly minimizes the potential damage.
Absolutely. That's the name of the game. Buy yourself time. And to do that, you need to build a really secure foundation for a Windows server. It starts with some core pillars. First, and this sounds basic, but it's critical, staying current with updates. Regularly applying Windows Server security updates, anti-malware definitions. It's like patching the known holes in your fortress walls. You just have to do it.
So how do organizations manage that? Is it just clicking check for updates?
Well, for smaller setups, maybe pulling directly from Windows Update is okay. But for larger organizations, you really need centralized solutions. Things like WSUS, that's Windows Server Update Services, let you control which updates get deployed and when, so you can test them first. Or more comprehensive tools like System Center Configuration Manager, SCCM, or even cloud-based solutions like the Operations Management Suite, OMS, which we'll probably touch on more later. These give you much more control and visibility.
Okay, so updates are step one. What's next for that foundation?
Configuring security settings properly. Microsoft actually publishes security baselines. Think of these as like pre-configured best practice security templates. They're derived from tons of real-world security experience, partnerships with government agencies. They know it works.
So you don't have to reinvent the wheel for every setting.
Exactly. They provide these baselines as group policy object backups GPOs. You can easily import these into your Active Directory Domain Services, ADDS, and apply them across many servers at once, or even apply them to standalone servers using local script tools. It saves a massive amount of time and ensures consistency.
Consistency, right. Avoiding those one-off misconfigurations that attackers love.
Precisely. And then you can never, ever underestimate the importance of scheduled backups. Consider them your lifeline. Frequent scheduled backups of the Windows Server OS, your applications, your data. Absolutely critical, especially for recovering from things like ransomware attacks where they encrypt everything.
Yeah, if they lock up your data, sometimes the only way back is from a clean backup.
It often is. Solutions like System Center Data Protection Manager or Microsoft Azure Backup Server can help you automate and manage this. Remember, a good, tested backup is frequently your last line of defense.
Okay, backups are non-negotiable. Now, you mentioned OMS earlier, the Operations Management Suite. Sounds pretty comprehensive. Tell us more about that.
Yeah, OMS, or now it's often integrated into Azure Monitor and Azure Sentinel, but the concept remains powerful. It's essentially a cloud-based IT management solution. It's designed to help you manage and protect both your on-premises infrastructure and your cloud stuff, kind of seamlessly together.
So a hybrid management tool.
Exactly. And what makes it really transformative are its core capabilities. First, insight and analytics. It collects, correlates, searches through logs, performance data from all your systems, giving you real-time operational insights. Basically, it tells you what's happening right now across your environment.
Like a central dashboard for everything.
Pretty much. Then there's security and compliance. It helps you identify and mitigate security risks using specific solutions for security auditing, checking anti-malware status, tracking software updates. It also brings powerful automation and control. You can automate administrative tasks using things like Windows PowerShell runbooks or desired state configuration, DSC, to enforce configurations.
Ah, automation again. Crucial for scale.
Absolutely. And finally, protection and recovery. It ties into things like Azure Backup for robust backup solutions and Azure Site Recovery for disaster recovery, especially useful for Hyper-V virtual machines. It gives you that holistic view and proactive defense system, all integrated.
That sounds incredibly powerful, having all that in one place. Okay, speaking of protection, let's zero in on what you call the digital crown jewels. Privileged identities. These are the accounts with the keys to the kingdom, right? Domain admins, enterprise admins, local administrators on servers.
Precisely. Once an attacker gets that initial foothold we talked about, these accounts are almost always their primary target. Gaining control of just one of these can give them complete control.
So how do these critical accounts usually get compromised? What are the common weak points?
There are several common ways, unfortunately. One big one is simply excessive privileges. Users having way more permissions than they actually need for their day-to-day job. Like maybe a DNS administrator who, for some historical reason, is also a full domain admin in Active Directory. That's unnecessary risk.
The principle of least privilege, then. Only give the access that's absolutely needed.
Exactly. Another major vulnerability is, well, constant elevated login. You see IT professionals staying logged into their privileged accounts all day long, even for routine tasks like browsing the web or checking email.
Oh, that sounds risky.
It dramatically increases the exposure time. If their machine gets compromised while they're logged in as admin, the attacker instantly gets those high privileges.
Makes sense. Keep the high privilege usage short and specific. What else?
Attackers are clever with social engineering too. Phishing is a classic example. They might trick someone into giving up credentials for a non-privileged account first, but then once they're inside, they use that access to poke around, research the network, identify who the admins are, and then target those accounts specifically.
So the initial breach might be minor, but it's a stepping stone.
Precisely. And then there are the more technical credential theft techniques, things like pass the hash or PTH or pass the token attacks. These allow attackers to essentially impersonate a user or steal their session without needing to know the actual password. They just need the hash value or the authentication token, which can sometimes be harvested from memory.
Wow, so even strong passwords aren't foolproof against those techniques.
Not entirely, no, which is why we need cutting-edge mitigation strategies specifically designed to counter these threats.
Okay, let's hear about them. What can organizations do?
All right, first up is something called Just Enough Administration, or JEA. This is a really cool security technology that uses Windows PowerShell remoting. It lets you restrict administrative rights with incredible specificity using role-based access control. Here's the magic part. You connect using your normal, non-elevated account credentials. But when you run specific allowed commands, JEA executes them behind the scenes using a temporary, highly restricted, elevated virtual account. You never actually log in with the full privileged credentials yourself.
Whoa, okay. So you get the power you need for a specific task, but without the full exposure of logging in as admin.
Exactly. It dramatically reduces the attack surface associated with privileged credentials. It's like having a very specific key for just one lock instead of a master key.
That sounds brilliant. What else complements that?
Complementing JEA nicely is just-in-time administration, or JIT. The concept here is simple. Elevated privileges are granted only when explicitly needed for a specific task, and only for a limited time, say, for 1 hour.
Temporary power-ups.
Pretty much. It usually involves a workflow. Someone requests temporary elevation. It goes through an approval process, maybe requiring multi-factor authentication or a manager's okay. Then temporary credentials are issued or the user is added to a privileged group. And crucially, after the time limit expires, that privilege is automatically revoked. Tools like Microsoft's Privileged Identity Management, PIM, in Azure AD, or even the simpler Local Administrator Password Solution, LAPS, for managing local admin passwords on workstations, are examples of JIT principles in action.
So JEA limits what you can do. JIT limits when for how long you can do it. That sounds like a powerful combo for shrinking that attack surface.
It really is. But we have more tools in the arsenal. There's Advanced Threat Analytics, or ATA. This is typically an on-premises product, though similar capabilities exist in the cloud now with Microsoft Defender for Identity. ATA excels at detecting identity compromise after it's happened, or as it's happening. It captures and parses network traffic, looking specifically at authentication protocols like Kerberos and NTLM.
How does it detect threats?
It builds behavioral profiles. It learns what's normal activity for users and devices on your network. Then, it uses machine learning and knowledge of known attack patterns to detect anomalies. Things like pass-the-ticket attacks, golden ticket attacks, which grant perpetual domain access, suspicious password sharing attempts, or unusual lateral movement across the network. It's like having a smart security guard who knows everyone's routines and flags anything weird.
That behavioral analysis sounds key for catching things that signature-based tools might miss.
It absolutely is. Then we have Credential Guard. This uses virtualization-based security, or VBS, which requires specific hardware features like secure boot and a trusted platform module, usually TPM 2.0. What it does is isolate and encrypt sensitive secrets, like the NTLM password hashes and Kerberos ticket granting tickets, TGTs, in a secure, virtualized container. Only highly privileged system processes can access this container, so even if malware gets kernel-level access on the machine, it still can't easily steal those credentials, hashes, or tickets from memory. It's like putting your most valuable keys in a virtual safe.
A hardware-backed virtual safe. Okay, that sounds robust.
It is, and building on that, specifically for remote desktop connections, there's Remote Credential Guard. When you connect to a remote server using RDP, normally your credentials might be sent to or stored on that remote server, making them vulnerable if that server is compromised. Remote Credential Guard prevents this. Your credentials stay securely on your client device. Kerberos requests are redirected back to your client for signing, so even if the remote desktop server you're connecting to is compromised, your credentials aren't exposed there.
Nice. Protecting you even when connecting to potentially untrusted machines. Okay, so we've put some serious locks on those privileged identities, but, even the strongest lock doesn't help much if the door itself is flimsy. Let's shift focus now to hardening the actual Windows Server operating system and the virtual environments it often runs. How do we secure the server itself?
Good point. There are several key features built into modern Windows Server for this. One is Control Flow Guard, or CFG. This came in with Windows Server 2016. It's designed to combat memory corruption vulnerabilities, which are a common way attackers try to hijack software execution. CFG basically adds checks before indirect calls in code, making sure the target address is a valid expected location.
So it makes it harder for attackers to redirect program execution to their malicious code.
Exactly. It disrupts a whole class of exploits. Then, of course, you have Windows Defender. It's the built-in antivirus and anti-malware solution. In Windows Server 2016 and later, it's optimized, enabled by default, and offers real-time protection, often leveraging cloud-based intelligence and network inspection capabilities. It's much more robust than older versions.
Okay, built-in protection is good. What about controlling exactly what software is allowed to run in the first place?
That's where Device Guard comes in. Now, this is often talked about as a group of features, including configurable code integrity policies. Essentially, it allows you, the administrator, to define exactly which binaries, applications, drivers, both user mode and kernel mode, are authorized to run on your server. Everything else is blocked.
So a whitelist approach.
Yeah.
Only run what's explicitly trusted.
Precisely. It's very powerful for preventing malware or any unsigned, potentially malicious code from executing. You can start in an audit mode to see what would be blocked, helping you build your policy without breaking things initially. Then you switch to enforcement mode. It works alongside, but is distinct from App Locker, which is often used more for managing user applications, including Windows Store apps.
Got it. And you mentioned Secure Boot earlier with Credential Guard.
Yes, Secure Boot is fundamental. It's actually a PC industry standard, part of the UEFI specification. It ensures that your device only boots using software that is trusted by the hardware manufacturer or by you if you configure it. It does this by checking digital signatures of the bootloader, the OS kernel, drivers. This prevents low-level malware like rootkits or bootkits that load before the OS from taking hold. It secures the boot process right from the start.
Okay, that's a really solid set of defenses for the server OS itself. But you mentioned virtualization environments, specifically Hyper-V. Why do they need special hardening? Isn't securing the host enough?
Well, securing the host is crucial, but virtualization adds another layer of potential risk. Think about it. If an attacker manages to compromise the Hyper-V host, the machine running all the virtual machines.
Ah, they could potentially affect all the VMs running on that host, right?
Exactly. The impact is magnified. A single host breach could compromise dozens, even hundreds of virtual servers. That's why Hyper-V has its own specific advanced security features.
Okay, what are those?
One major concept is guarded fabric and shielded virtual machines. This is designed to significantly strengthen security for the VMs themselves, particularly protecting their state, their memory files, their virtual disks from inspection or tampering, even by compromised host administrator.
Who does that work? Shielded VM sounds cool.
It is pretty cool. A guarded fabric involves setting up a separate, highly secured service called the Host Guardian Service, or HGS. Hyper-V hosts in the fabric have to prove their health and integrity to the HGS through a process called attestation. Only healthy, trusted hosts are given the cryptographic keys needed to power on and run these special shielded VMs. The shielded VMs themselves have their virtual disks encrypted, their live migration traffic encrypted, and even console access is restricted.
Wow, so it creates this trusted environment where only verified hosts can run these super protected VMs. That's a serious chain of trust.
It really is. And related to this, Windows Server 2016 and later also support a Virtual Machine Trusted Platform Module, or VPPM. This allows Generation 2 Hyper-V VMs to have their own virtual TPM chip. Why is that useful? Well, it enables security technologies inside the VM that rely on a TPM, like BitLocker drive encryption for the VM's operating system disk.
So you can encrypt the VM's disk from within the VM itself using BitLocker.
Exactly. And that VTPM's keys can be protected locally, or for higher security, they can be guarded by the host guardian service we just talked about, ensuring only authorized fabrics can decrypt and run the VM.
Okay, that secures the VM's data at rest. What about network security between VMs?
Good question. For that, there's the software-defined networking SDN microsegmentation firewall, often just called the data center firewall in Windows Server. This allows you to centrally define and manage firewall policies for your virtual machines, protecting traffic between VMs on the same host or across the network.
So finer grain control than just a perimeter firewall.
Yeah. Much finer. It's a stateful, multi-tenant firewall. You apply access control lists, or ACLs, directly to the virtual network interfaces of individual VMs. And these policies are enforced consistently by the Hyper-V host's virtual switch, and critically, the policies follow the VM if it gets live migrated to a different host. It ensures consistent, granular network protection for your virtualized workloads, regardless of where they run.
That seems essential for modern dynamic data centers. Okay, that's a lot of incredible, sometimes complex technology for securing servers and VMs. But let's bring it back down to the sysadmin's daily grind. What about their essential digital toolkit? Particularly, are there free tools that can make a real difference in troubleshooting and security? Not everything costs a fortune, right?
Absolutely not. There are some fantastic free tools that are indispensable. Let's start with network troubleshooting. You've got the classic powerhouses like Wireshark. If you need to see exactly what's happening on the wire, packet by packet, Wireshark is the gold standard for deep analysis. And Microsoft has its own tool, Microsoft Message Analyzer, or MMA. While it's technically deprecated now, its successor concepts live on in tools like NetTrace. What was unique about MMA and what you look for in modern tools is its ability to correlate system events like application logs or system call traces with the network traffic.
So you could see, like, this application made this system call, which resulted in this specific network packet.
Exactly. That correlation can be an absolute game changer when you're troubleshooting weird application behavior that seems network-related or tracking down complex configuration issues.
That sounds incredibly useful.
And of course, never forget the basics. Your first steps for any network issue should probably be ping to check basic connectivity and reachability, and tracer D or traceroute on Linux Mac OS to see the path packets are taking and where they might be getting dropped, without trying to resolve host names, which can slow it down.
Right, the fundamentals are still fundamental. Okay, beyond network stuff, what about general system management and maybe more importantly, security investigation tools?
For remote management, the Remote Server Administration tools, or RS8, are invaluable. These aren't a single tool, but a package you install on your Windows 10 or 11 workstation. They give you all the familiar management consoles, Active Directory users and computers, DNS manager, group policy management, etc., allowing you to manage your servers remotely from your own desk.
And why is that better than just using remote desktop, RDP, to log into the server?
Huge security benefit. Every RDP session to a server increases the attack surface on that server. If your workstation gets compromised while you have an RDP session open to a domain controller, for instance, the attacker might be able to piggyback or steal credentials. Using RSA means you're running the management tools locally and they're communicating with the server via specific management protocols, which is generally much more secure than having a full interactive desktop session running on the server itself.
Ah, okay, that makes perfect sense. Less direct exposure for the servers.
Mm.
What else for digging into system internals or investigating potential breaches?
Then you absolutely have to talk about the SICE Internals suite. This is a legendary collection of, I think it's over 70 now, free utilities created originally by Mark Rusinovich and Bryce Cogswell, now part of Microsoft. These tools give you incredibly deep insights into Windows internals for troubleshooting, diagnostics, and security investigation.
SICE internals, yeah, I've definitely heard of that. What are some highlights from the suite?
Oh, there are so many gems. Process Explorer is a must-have. Think of it as Task Manager on steroids. It shows you way more detail about running processes, which files and registry keys they have open, their CPU and memory usage graphs, DLLs they've loaded, their security context, digital signatures. It even integrates directly with VirusTotal, so you can right-click a suspicious process and instantly check its hash against dozens of antivirus engines.
Wow, VirusTotal integration built in. That's handy.
It's incredibly useful for quickly identifying potential malware. I remember using it once to track down a really persistent weird network connection that standard tools couldn't pin down. Process Explorer showed me this hidden process, no clear parent, unsigned, right-click, check VirusTotal, bam, confirmed malicious. It was the key piece of evidence.
That's a great real-world example. Any other standouts from sysinternals for security?
Definitely System Monitor or Sysmin. This isn't a GUI tool you run, but a service you install. It enhances standard Windows event logging with much more detailed information about things like process creation, including command lines, network connections being made by processes, driver loading, file creation events, registry modifications. The level of detail Sysmin provides is invaluable for security incident response and threat hunting. It gives you the breadcrumbs you need to reconstruct what an attacker did.
So it provides much richer logs for later analysis.
Exactly. And maybe one more from the suite, Access Trick. This is a command line tool that lets you quickly see what permissions specific users or groups have on files, directories, registry keys, Windows services, and more. Really useful for auditing permissions and finding potential misconfigurations that could lead to privilege escalation.
Okay, this internal sounds like a treasure trove.
Yeah.
What about other useful freebies? Backup maybe, or productivity?
Yeah, a few others come to mind. For backup and disk imaging, Clonazilla is a very popular open source tool. Great for cloning disks, creating system backups, and disaster recovery. Its server edition can even deploy OS images to many PCs over the network. For file compression, 7-zip is fantastic. High compression ratios, supports tons of formats, open source, and offers strong AES 256-bit encryption for archives. For editing text files, config files, scripts, or huge log files, Notepad++ is way better than standard Notepad. Highly customizable, syntax highlighting for dozens of languages, powerful search, including regular expressions, handles large files well. It's a developer and sysadmin favorite.
Notepad++, and yeah, I use that one myself. Very handy.
Right. Specifically for Active Directory account lockouts, which can be a real headache for help desks, Netrix Account Lockout Examiner is a free tool that helps quickly pinpoint why an account keeps getting locked out, which machine it's happening on, failed login attempts, etc. Saves a lot of troubleshooting time.
That sounds like it could reduce a lot of support calls.
It really can. And maybe one more alternative to Process Explorer is Process Hacker. It's also open source and offers similar deep insights into processes, but has some unique features people like, such as clearer highlighting, more detailed disk and network activity tabs, and easier ways to manage services and drivers. Some people prefer its interface.
Options are always good. And for remote command line access.
For connected Linux servers or network devices like switches and routers via SSH, PuTTY is the classic lightweight free terminal emulator. It's simple, fast, supports SSH, Telnet, SCP, RLogin, just does the job reliably. Still a go-to for many people.
That's a fantastic list of practical free tools. It really shows you don't always need expensive software to get things done effectively. Now, you mentioned it a few times, and it feels like the elephant in the room for modern Windows administration.
Yeah.
Let's really dive into what many consider the automation superpower, PowerShell. What exactly is PowerShell, and why is it considered so incredibly powerful, especially for sysadmins?
Right, PowerShell. It's incredibly versatile. At its heart, it's both a command line shell, like the old cmd.exe, but also a powerful scripting language built on top of Microsoft's .NET framework. And that .NET foundation is key. Unlike older shells that primarily deal with strings of text, PowerShell works with objects.
Objects, not text. Why is that such a big deal?
Because objects have properties and methods, they carry structured data. When one PowerShell command outputs an object, you can directly access its properties or pass that whole structured object to the next command in a pipeline. This makes it vastly more powerful and flexible for automation than just parsing text output. You're working with real data, not just character strings. That's why it's so crucial for desktop and server admins today. It allows for automating complex tasks, managing remote machines at scale, implementing infrastructure as code, leading to huge time savings and much greater consistency in configurations.
Okay, so the object-oriented nature is the secret sauce.
Mhm.
What are the fundamental building blocks you work with in PowerShell?
The core building blocks are CMDlets, CMDLETS, pronounced commandlets. These are the built-in commands, usually following a verb-noun naming convention like get process or stop service. They perform specific actions, and critically, they output those .NET objects we talked about.
Get process, stop service. That naming seems pretty intuitive.
It's designed to be discoverable and consistent, yeah. Now, the real power comes when you chain these CMDlets together using the pipeline operator, which is the vertical bar symbol. This takes the object output from the command on the left and feeds it directly as input to the command on the right. You can build really sophisticated one-liners this way. For example, get process, where object $CPU down GT 100 stop process. That gets all processes, filters them to find those using more than 100 seconds of CPU time, and then stops them, all based on object properties.
Wow, okay. That's much cleaner than trying to parse text output from a command.
Exactly. And when you want to combine multiple CMDlets and add logic, error handling, loops, etc., you write a script. These are just plain text files, usually with a .ps1 extension containing PowerShell code. Scripts allow you to automate complex, multi-step tasks, schedule them, and run them remotely.
Got it. CMDlets are the verbs, pipelines connect them, scripts orchestrate them. How do you actually set up and, importantly, secure PowerShell?
Well, PowerShell comes pre-installed on all modern Windows versions, which is great. You might need to install a newer version sometimes, as Microsoft updates it frequently. And importantly, it's also cross-platform now. You can install PowerShell Core on macOS and various Linux distributions.
Cross-platform, interesting. What about security? Running scripts sounds like it could be risky.
It definitely can be, which is why PowerShell has a built-in security feature called the execution policy. This is crucial to understand. It restricts whether scripts can be run, and if so, which ones. By default, on Windows clients, it's often set to restricted, meaning no scripts allowed at all. On servers, it might be remote signed.
Remote signed. What does that mean?
Remote signed means you can run scripts that you wrote yourself on the local machine, but any scripts downloaded from the internet must be digitally signed by a trusted publisher. Other policies include all signed, all scripts must be signed, or unrestricted, which allows any script but is generally not recommended for security reasons. You need to use the set execution policy CMDlet carefully to choose the right balance for your environment.
Okay, so execution policy is a key control. What else?
Modules are another important concept. PowerShell itself has a core set of CMDlets, but its real power comes from installable modules. These are packages containing additional CMDlets, functions, variables, etc., usually focused on managing a specific technology. There are modules for Active Directory, Microsoft Exchange, SQL Server, Azure, AWS, VMware. Pretty much anything you'd want to manage. You import the modules you need.
So modules extend PowerShell's reach.
Massively. And for actually writing and debugging scripts, especially longer ones, the PowerShell Integrated Scripting Environment, or IEU, is really helpful. It's a graphical tool built into Windows. It gives you a script editor with syntax highlighting, IntelliSense, that code completion feature, a command pane to run things interactively, and importantly, integrated debugging tools like setting breakpoints and stepping through your code line by line. It makes development much easier than just using Notepad.
The IE sounds like a must for anyone serious about scripting. Okay, let's get practical. Give us some concrete examples of how sysadmins use PowerShell to make their lives easier or improve security.
Oh, tons of ways. We touched on Active Directory earlier. Imagine onboarding not 50, but 500 new users. With PowerShell, you can script reading user data from a CSV file, creating the AD accounts, setting passwords, assigning them to the correct groups based on department, setting up their home drives, enabling their mailboxes, all automatically and consistently.
That scales incredibly well compared to manual clicking.
Night and day difference. Or think about managing files and folders. You could script finding all files older than X days in a specific folder structure and moving them to an archive location. Or systematically setting specific tools for PowerShell, VMware PowerCLI. You can manage large parts of your hybrid cloud infrastructure using the same consistent language and techniques. It's a hugely valuable skill.
Okay, it's clearly powerful. But scripting can also go wrong. When things inevitably break, what are some troubleshooting fundamentals, especially when dealing with PowerShell scripts? It can't always be smooth sailing, right?
Definitely not. Scripts break, logic fails, environments change. First, as always, revisit basic troubleshooting. If your script is trying to connect to a remote machine and failing, use ping or a testnet connection to check basic network connectivity first. Don't assume the script is wrong if the network is down.
Good point. Check the foundation. What about issues within the script itself?
Common script issues include simple syntax errors, maybe a misplaced bracket or comma. PowerShell's error messages are usually pretty good at pointing you to the line number. Other common problems are using variables incorrectly, trying to access a property on an object that doesn't exist, especially if a previous command failed silently and didn't return the object you expected, or maybe relying on a PowerShell module that isn't actually installed or loaded on the machine running the script.
So how do you diagnose those? Staring at the code?
Sometimes, but the PowerShell ISC's debugging tools are your best friend here. We mentioned them earlier. You can set breakpoints on specific lines. When the script hits a breakpoint, it pauses execution. Then you can examine the current values of all your variables, see exactly what state things are in. You can also step through the code line by line using F10, step over, or F11, step into functions. This lets you watch the execution flow and see precisely where it deviates from what you expected. And simple write host or write debug statements sprinkled throughout your code can be invaluable just to print out variable values or messages like reach this point to track progress.
Okay, so using the debugger and adding some diagnostic output seems key to finding those tricky logic bugs.
Absolutely. It turns debugging from guesswork into a systematic process.
And once you have a script working, are there ways to make it, better, more efficient?
Yes, definitely. Script performance can matter, especially if it's doing a lot of work or running frequently. Some tips. Minimize redundant code. Don't repeat the same operations multiple times if you can avoid it. Try to use PowerShell's optimized built-in C MDLets where possible. They're often written in C# and faster than achieving the same thing with pure script logic. And leverage those pipelines effectively. Passing objects directly down the pipeline is usually much more memory efficient and faster than, say, storing a huge collection in a variable first and then iterating over it with for each object. Filter early. Filter often using where object.
Filter early. Okay, that makes sense. Don't process data you don't need.
Right. Writing efficient PowerShell is a skill you develop over time.
Which brings us to a really important point, I think. The continuous learning journey. PowerShell, and IT in general, isn't something you learn once and you're done, is it?
Not even close. PowerShell might seem a bit technical or intimidating at first, especially if you're not from a coding background, but its syntax is actually designed to be quite approachable, and the community support is huge. With practice, it becomes incredibly powerful. But technology changes constantly. New versions of Windows Server, new cloud services, new security threats, new versions of PowerShell itself. Continuous learning is absolutely essential.
How do professionals typically keep up?
Reading blogs, engaging in online communities, attending webinars or conferences, and pursuing professional certifications are all common ways. Certifications especially help build targeted skill sets, validate knowledge to employers, keep you current, and definitely enhance career prospects. The role of the system administrator is constantly evolving. There's increasing emphasis on automation, cloud management skills, Azure, AWS, GCP, DevOps practices, and, as we've heavily discussed, robust security practices woven into everything they do.
So the modern sysadmin needs to be part engineer, part security expert, part automation guru.
And a lifelong learner, absolutely. Adapting to new threats and new technologies is just part of the job description now.
Well, this has been incredibly insightful. We've really journeyed through the whole dynamic world of system administration today. We've understood the essential, often unsung role of the sysadmin, grasped the significant and evolving cyber threats they constantly face, and explored the powerful multi-layered strategies and tools available to secure Windows Server environments. We covered everything from those foundational practices like updates and backups to advanced identity protection like JEA and JIT, hardening the OS and Hyper-V with features like Device Guard and shielded VMs, and finally, leveraging that automation superpower, PowerShell, along with a toolkit of essential utilities.
It's a complex landscape, but hopefully we've helped demystify some of it. So maybe a final thought for you, our listener. We live in an age where digital infrastructure truly forms the backbone of nearly everything we do, business and personal life included. How does your enhanced understanding of system administration and security from this deep dive change the way you interact with and think about protecting the digital world around you? Are you perhaps looking at your own connected devices, your company's network, even the services you use online with, let's say, new eyes? Recognizing those intricate layers of defense that are hopefully in place, or maybe spotting the potential vulnerabilities now that you have a few more pieces of that secret decoder ring,